Andrew Cresses, and today we're going to talk about the physics of breakfast. It's the latest lecture from our physics class, and some of the interesting things about it were what happens to coffee particles when coffee droplets evaporate, how eggs cook, a little in depth, and some things about cereal floating on water and polarity. One thing I learned that I didn't know is that coffee droplets, when they evaporate, they don't just flow out like this. They actually start with this hump shape and then evaporate in the middle and the sides stay pinned down. It actually makes kind of sense because you always see the rings, and that's what a lot of the discussion was about. A lot of things I learned that I did know about was the eggs specifically, because I had taken a couple biology classes and learned a lot about the denaturing of proteins when they cook. When the eggs cook, it's not naturally the water evaporating that cooks them, but it's the denaturing of the proteins as they heat up and the enzymes no longer function. The water is what I'll be going into next. It really sparked my curiosity because it reminded me of something that my dad did when I was younger. He showed me this interesting experiment involving a bowl of water in which you sprinkle pepper flakes onto the surface. The surface tension keeps the pepper flakes afloat on top of the water, but if something is to break the surface tension, they will flow outwards and sink to the bottom. It's a very interesting experiment dealing with surface tension. Here's a video of it. The polar water molecules are attracted to the polar tail of the soap molecule, which in turn breaks the surface tension and the meniscus of the water, allowing the pepper to flow to the edges. As you saw in the video of the experiment, the soap, when it encounters the water, the polar ends of the soap molecule, because soap is designed to have one non-polar end that can react with oils so as to clean them off of your hands and body, and then a polar end so as to react with water so that you can wash it off a little bit easier. But when the polar end interacts with the water molecules, it attracts them inwards and breaks the surface tension of the water. This, when the meniscus forms in the water, this breaks the meniscus and the water drops and flows outwards. This is why the pepper particles all flow outwards. It's not because they're repelled by the soap or anything like that. And it's not because you're just touching the water. If you were to do this with, say, olive oil or anything else that's not polar, you just touch the water and nothing would happen. The meniscus would stay, the particles would stay, everything would be stagnant. But because of the polarity of that one tail of the soap molecule interacting with the water, it breaks the surface tension and the pepper moves.